Hello 108 students, Ms. McHugh here. Welcome to Chapter 3 where we're going to be dealing with graphs, linear equations, and functions. To get this chapter started, we are going to go ahead and tackle 3.1, rectangular coordinates, and of course we're going to go ahead and do page 1 to get going. Okay, so objectives 1 and 2 out of the book here. You're on page 137, 138, roughly 136. And I have summarized real quickly that linear equations can be graphed, and we are going to use the Cartesian coordinate plane. Think of a city grid of blocks, streets that run north and south, and streets that run east and west. And we do this here in the Boise area with our roads are about a mile apart. And so real quickly, I just want to review, we always start with the x-axis as horizontal, positive to the right, negative to the left. The y-axis is positive going north, up, and negative going down. Okay, and so we have, think of integers, 1, 2, 3, 4, 5. Going left on the x-axis is -3, -4, here's -1, just to kind of get you going. Positive on the y, 1, 2, 3, 4, here would be 5, positive 5. -5 would be -1, 2, 3, 4, about right here would be -5. Okay, so there are 4 quadrants, 1, 2, 3, 4. If you pick ordered pairs real quick, if I go, always go x comma y. This is the definition of ordered pairs. Always x, which is left, right, the order, and then comma, the y-axis is up or down, positive up, negative going down. So to find where you are on the grid, that's my nickname for this, I might turn around and tell you start right at downtown Boise at where Capitol and where the City Hall is at. I think it's Main Street. If I tell you to go 2 blocks east, you would go 2 blocks this direction and then go 3 blocks north, and you'd be at the ordered pair 2, 3. Now we don't say blocks when we're talking mathematics, but just trying to help get the idea going. So the ordered pair 2, 3, you always start at the origin, and at origin is the ordered pair 0, 0. Okay, so let's pick up the pace. 2, 3. Notice everything in the first quadrant is positive, positive. Second quadrant, to get to this ordered pair, -3, 1, start from the origin, go back 1, 2, 3, go up 1, and there's where you would be. Everything in the second quadrant is a negative x and a positive y. What happens in the third quadrant? Start from the origin. Always go back to the origin. It's the starting place. Find -2, -2. -2 would be to the left. Down -2 would be 1, 2 right here. And there's where -2, -2. Everything, all the ordered pairs in the third quadrant are negative, negative. Finally, the fourth quadrant, remember we're kind of going this way counterclockwise. I always remember this by starting in the first quadrant as positive, positive, and go counterclockwise. Okay, quadrant 4, to find 4, -3, start from the origin, 1, 2, 3, 4, positive 4, -3, go down, 1, 2, 3, and you'd be right here. Okay, so that's the basic fundamentals. Every ordered pair, every intersection of vertical lines and horizontal lines can be, can be represented by a ordered pair. Objective 2 is getting you into working with a linear equation. Definition of a linear equation has an x term and a y term equal to a constant. This is called standard form. Now, every ordered pair must satisfy this equation if it's on the line, if you're going to graph them. So they're going to start off and tell you if x is -3, substitute it in the equation and find what the corresponding y would be. 2 times -3, -6. Add 6 to both sides, gives you 3y equals 12, divide by 3, and you get y equals 4, and that's the corresponding y coordinate of the ordered pair. So -3, 4 satisfies the equation. You put both these values in, -3 for x, 4 for y, and you will get 6 equals 6. Okay. Sometimes they'll give you a problem and they'll give you the y coordinate and ask you what the x coordinate is. Simply take the y value, stick it into the linear equation, and evaluate and solve for x. So -4 times 3 is -12. Add 12 to both sides, divide by 2. X equals 9 gives you the ordered pair 9, -4. Okay, those are pretty warm-up exercises here. Now they're going to ask you to graph. We're going to do various different techniques. This is just to get it going. This you're not going to use too much. But if you were given a standard form, ax plus by equals c. Now this is one of the first forms you could put into your reference sheet for this chapter that you could use on the test. You just think of this as the x term plus the y term equals a constant. Okay. The variables x and y are your true variables. A, b, and c are constants. They're going to be numbers. Okay, here's an example. 2x plus 3y equals 6. They tell you to graph it. Well, up in the work beforehand, we found the ordered pairs -3, 4, which should be right here. And we found 9, -4, which would be about right here. 2 points determine a line, and then you can draw it. Okay, notice what I did here was on the where did the line cross the x-axis? Here at 3, 0. That's called the x. That's the x-intercept. We're going to use this technique in a little bit. Notice the value for y. It's 0. Notice the y-intercept is 0, 2 when it crossed it. Notice the value for x. We're going to use this here on the next page or two coming up. Okay, now on MyMathLab, when you start doing graphing, you've got to find the tool that looks like a line and it's got 2 dots to it. You're going to turn around, find the first ordered pair that you find, click on the tool, snap it down. As you move it around, a line will appear. Find the second one, like 9, -4, click again, and it'll snap the line down for you. Okay, that's just to help you out with MyMathLab a little bit. Okay, Mr. McHugh, here we wrapped up page 1. We got lots to do in this chapter, so let's go ahead and I'll see you on page 2 for section 3.1. Okay, bye.